Hi guys. So we're going to go over last week's problems for the assignments, and you can go ahead and do corrections if you need to. We are going to start with our week 4 lesson 1, and that was our standard trigonometry, what we do when we're missing a side. And then we'll move on to our week 4 lesson 2, which was inverse trigonometry, which is what you use when you're missing an angle. So let's go ahead and start with week 4, lesson 1, problem 1. It says, Suzanne and Mindy were solving the problem below involving trigonometric ratios for their homework. Which of the following would help the girls find the value of y? So you see, I already have some notes here because I had helped you set this up in the previous video. If you haven't watched that video, I recommend doing that one first. So we are interested in y, the side y. And we are given a 90-degree angle here, a 61-degree angle here, and z, which is unknown. Well, what I want to explain on the last video is that you should focus on the 61-degree angle because it is a given angle that is not the 90-degree, and all of your answer choices are clearly within relation to the 61-degree angle. So what we're going to do is we are going to look at our sides. So the first thing we know is that our adjacent side is y, our hypotenuse is x, and our opposite side is 13. All right, and that's in relation to the 61-degree angle here. Don't forget that. All right, so we're going to see we have information for the opposite side, and we're solving for y, which is the adjacent side. So let's set up. We have opposite and adjacent. Opposite and adjacent means we are going to use tangent to solve because tangent is equal to opposite over adjacent. So tangent of a 61-degree angle is equal to opposite, which is 13, over adjacent, which is y. And so if we look at our answer choices, the one that matches is A. All right, number 2. Which expression can be used to find the length of line segment AT? Now, one important thing that I didn't point out in the previous problem that is also important in this one is they were only interested in the expression. They did not ask you to solve for the length of AT. So looking at our triangle, we see that AT is our hypotenuse, which we labeled in the previous video. And we can go with either angle if we really want to. But again, look at our answer choices. They care about the 66-degree angle. All right, not the other angle, which we could figure out mathematically if we wanted to. So we have the 66-degree angle, which is angle A, as I labeled earlier, which means we have our hypotenuse. If one side of our angle is the hypotenuse, we need to remember that our remaining side is always adjacent, and the side that is not highlighted or colored becomes opposite. It is very important that you pay attention and label the triangle after you've identified your angle. All right, so it wants to know which expression. So let's look at the information. Our hypotenuse is the unknown AT that we are looking for. Our opposite is unknown, and our adjacent is 12.5. So we need to look at what we have. We have an angle of 66 degrees. We have a hypotenuse that we're solving for, that is our unknown, and our adjacent, which is known. So we have hypotenuse and adjacent. Which trigonometric ratio uses hypotenuse and adjacent? Well, that's going to be our cosine because it's ka. So katoa, don't forget. So we're going to set this up as the cosine of a 66-degree angle is equal to the adjacent, which is 12.5, over the hypotenuse, which is unknown. And so I'm going to call the hypotenuse just AT because that's what it is. So we need to get AT by itself. Remember, whenever we're solving for the hypotenuse, which means or our unknown is in the denominator, we can just switch these two. Because if we look, none of our answer choices match that. But we can eliminate C and D because they're using sine, and we went with cosine. So AT is 12.5 over the cosine of 66, and that is going to be answer choice A. All right, so number 3. On the map below, Main Street, 10th Street, and Highway 1 intersect to form a right triangle. The distance between 10th Street and Main Street along Highway 1 is 5.6 miles. So between 10th Street and Main Street, this is 10th Street and this is Main Street. So it's 5.6 miles along Highway 1. Which measure is closest to the length of Main Street from High Street or Highway 1 to 10th Street? So we're solving for X. So let's look at the angle that's given to us. We have our 90-degree angle and we have a 40-degree angle right here. So the angle we're interested in focusing on is this one right here. And so if this Main Street, which is X, is our hypotenuse, 10th Street is adjacent, which means Highway 1 is opposite. So we know that our opposite is 5.6. Our adjacent is unknown. And our hypotenuse is X. And X is what we're looking for. We care about X. So let's say we look at this. We have opposite, we have hypotenuse. Opposite and hypotenuse are used in sine because that's our So let's go ahead and set up our problem. So we are using sine. Our angle is 40 degrees. Our opposite is 5.6. And our hypotenuse is unknown. So remember what I said in the previous problem. When you're solving for the denominator, you can simply switch it with the other side of the equal sign. So X is equal to 5.6 over the sine of 40. So let's go ahead and pull up a calculator and solve for this problem. Okay, so here's my calculator. I am going to use the TI Nspire emulator because it is the one that is easiest for me to access. Remember, there is a very good graphing calculator and scientific calculator at desmos.com. Link in the description below. So we are going to go 5.6 divided by, hit our trig button, go with sine of a 40-degree angle, hit enter, we get 8.71. Since it asks us which measure is closest, we're going to choose A, 8.7. Moving right along, we're going to set up problem 4. We're not solving, we're just setting up. So the question it's asking is which expression can we use to find the length of line segment QR in centimeters. So we're only caring about the expression, and it's the one that's used to find. So let's go ahead and look at the angles we're given. We are given a 90-degree angle and a 20-degree angle. So the angle we're going to focus our attention on is angle S, which is 20 degrees. We need to label our hypotenuse, which is opposite the 90-degree angle. Remember, I said label your hypotenuse first because that one is always in relation to the right angle. Now, your hypotenuse and your adjacent will be the sides that you highlighted when you indicated your angle. So this side, 19, RS, is our adjacent side, and QR is our opposite side. So now we want to look at what information we already have. So again, hypotenuse is unknown. Opposite is line segment QR, which is also unknown but what we are solving for. And adjacent is line segment RS, which is 19 centimeters. So we have an opposite and adjacent that we have relevant information for or that we are searching for. So if we have opposite and adjacent, we're going to use tangent, which is opposite over adjacent. Our angle is 20 degrees, so we're going to put tangent of 20 degrees is equal to opposite, which is a QR, over 19, which is adjacent. And then we're going to get QR by itself. So line segment QR is divided by 19. So we need to multiply both sides by 19, and we get 19 times the tangent of a 20-degree angle is equal to the length of line segment QR. So 19 tangent 20. Okay, so number 5 is a very common trigonometry style of problem. It says a tree's shadow is 4.8 meters long on ground level as shown in the diagram. The angle of elevation from the tip of the shadow to the sun is 50 degrees. Based on this information, which of the following is closest to the height of the tree? So we're looking for side of our triangle. So let's go ahead and label our triangle and indicate our angles. So the first thing we're going to do is identify our hypotenuse. And because ideally the tree forms a right angle with the ground, that's what we're going to assume. That means the sunbeam is the hypotenuse. We are focused on the 50-degree angle here that the sunbeam makes with the shadow. What's really looking at is it's actually a person looking up at the top of the tree. So line of sight. If the line of sight is the hypotenuse, then the length of the shadow must be the adjacent because the angle is made with the line of sight or angle of elevation and adjacent is the ground. And that tells me that the tree is the opposite side of our imaginary triangle. So we need to label what we know. Hypotenuse is unknown. Opposite is the tree. Adjacent is the shadow, which is 4.8 meters. And we are focusing on a 50-degree angle. So we have adjacent, and we are looking for the opposite. So opposite and adjacent. Which trigonometric ratio should we use? We should use tangent because tangent is opposite over adjacent. So we have the tangent of a 50-degree angle is equal to our tree, which is unknown. I'm going to put x, over our adjacent side, which is 4.8 meters. We're going to take the 4.8 and multiply both sides by 4.8 so that x can be by itself. So x is equal to 4.8 times the tangent of a 50-degree angle. And we're going to run that through the calculator. Okay, so in our calculator, I typed 4.8 times the tangent of a 50-degree angle, and I get 5.72. So if x is approximately 5.72, then the answer to our question is B, 5.7. All right, so again, what do we do if we have our sides, but we're missing an angle instead? We're solving for an angle. Because it's something different, when we were solving for sides, we used standard trig, and in a triangle, essentially, the opposite of a side is an angle. So in inverse trigonometry, we will be solving for angles, missing angles. So number 1 says, which expression can be used to find the measure of angle D in degrees? So the first thing I did when I did this on the previous video was probably label my hypotenuse, which is opposite my 90-degree angle. So there's my 90, hypotenuse is opposite. I highlighted the angle I was focusing on, which is angle D, which told me that the other side touching angle D Angle D is made up of the hypotenuse and the adjacent. So DE is adjacent and EF is opposite. So over here, we do not know what angle D is. Adjacent is unknown, but not needed. Opposite is 5 and hypotenuse is 13. So we know we're missing an angle. We're going to figure out which function we would use first. We have opposite and hypotenuse, so that means we're going to use sine. So we only have one answer choice that has sine as an answer choice. So that's one good thing to pay attention to, but let's go ahead and set it up. Whenever we notice that we have an angle missing, we know that we're going to put sine of D is equal to 5 over 13, opposite over hypotenuse. We don't know what sine of D is, so we're going to take the inverse, and angle D is the inverse sine of 5 over 13. So whenever you see a missing angle, you can go straight to inverse trigonometry. Okay, same triangle, only now we are focused on angle F instead of angle D. So what that does is that changes because angle D and angle F are on opposite sides of the triangle from each other from the hypotenuse. That means EF is now the adjacent side and DE is now the opposite side. Remember, it's based on which angle you are focusing on. And now we're focusing on angle F. So we have adjacent and hypotenuse. Adjacent and hypotenuse go with cosine. So we know we are doing the cosine of angle F. We know we're looking for an angle, so we're going to go ahead and default to inverse trigonometry. And the ratio is the same. So adjacent, which is 5, over hypotenuse, which is 13, and that makes our answer A. Although again, it is the only answer that had cosine in it. Now, number 3 does specifically ask us which answer is closest. So that means we are going to be using a calculator for this one. And it says angle B. So let's focus on angle B. Highlight angle B. Now we need to determine our hypotenuse. So here is our right angle, angle C. Across from angle C is line segment BA. That is our hypotenuse. And the other side touching angle B by default will be our adjacent. And the last remaining side, which is opposite angle B, is of course our opposite. So let's make our list. Hypotenuse is 5. Adjacent is 2. Opposite is unknown. But again, we only need two sides to find an angle, so we don't need the opposite. So we're looking for the measure of angle B. So we need to figure out which function we're going to use. We have adjacent and hypotenuse. So we are going to use cosine because SOHCAHTOA, cosine is adjacent over hypotenuse. So we're going to default to inverse because we're looking for an angle. Adjacent is 2. Hypotenuse is 5. And we are going to run that through our calculator. Many calculators have your inverse trig functions directly underneath your original trig functions. So we just have to go to cosine inverse, 2 divided by 5, and hit enter. And we get a 66.42 degrees. Right? So measure of angle B is approximately 66.42 degrees. And the closest is C. Okay, so number 4 says the depth sensor on a boat shows that the boat is 57 feet above the sea floor. The rope that holds the anchor is 80 feet long, as shown in the drawing below. Approximate the angle of depression from the boat to the anchor on the sea floor to the nearest tenth of a degree. So we are basically looking at this angle because it's the anchor and the sea floor. Also, we know that this angle and this angle are complementary, so that this angle right here, the boat to the rope, is equal to the anchor to the ground, okay? Because we're pretending that the water is parallel to the ground. And then it also tells me that the boat is 57 feet above. So what is the approximate angle of depression from the boat to the anchor on the seafloor to the nearest tenth of a degree? So let's make our list. If we look at this angle here, we are going to have our hypotenuse is 80 degrees, or sorry, 80 feet, and our adjacent side is the ground, and 57 feet is the opposite side. So let's make our list. Hypotenuse is 80 feet, opposite is 57 feet, and adjacent is unknown. So we're going to set up our inverse trig ratio. We know we have hypotenuse and opposite, so that tells me sine. So our angle is equal to the inverse sine of opposite, which is the depth of 57 feet, over the hypotenuse, which is the rope of 80 feet, and then we're going to run that through our calculator. Okay, so if we take inverse sine of 57 over 80, we get 45.43. And so our closest answer is C, 45.4, because we would round to that. So that's what you need to make sure you're doing. Now, if you are using Desmos instead of an emulator or the calculator on your computer, you are going to go to desmos.com. We are using the scientific calculator. And again, here's your sine, cosine, tangent. If you hit the ABC button here, sorry, the function button, if you hit the function button, it does give you your sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent. So just make sure you pay attention to where those symbols are located. Okay? I'm going to wrap this up here. If you have any questions, I will be having live chat tonight, Thursday the 23rd, and then following Tuesday and Thursday. You can leave questions in the comments, but the faster way is to contact me on Google Classroom or via email. Have a great day, guys. I will see you soon.